All right, everyone. Good morning or good afternoon. This is my very first attempt at a video lesson. So I thank you in advance for your patience as I learn the best way to embark upon this distance learning that we unfortunately need to do for the foreseeable future. However, math waits for no person. It is out there, and we need to continue our studies in math. Here is how things are going to work. I'm going to attempt to post a video every day about the topic of the day. I will try to model a problem or two, and then I'm going to ask you to complete anywhere between 3 to 5 or 6 problems on your own. I would like if you print off the problem set that I post and you do the work there and you have a scanner, feel free to scan a copy of the work you do onto our Google Classroom. If you are just going to write the work on a piece of paper, just take a picture with either your Chromebook or your phone and just submit the work that you've done as an image or as a file to the Google Classroom, so I could just check to make sure that you've all done the work and we are keeping up with the work. My main objective here is to make sure that we are ready for high school and we have the necessary skills through the end of our geometry course to be ready to go for Honors Algebra 2. All right, so we're just going to jump into it. We are going to start with where we left off, which is the altitude on hypotenuse problem. So you could see here that we have a right triangle A, B, C, A, B, C. From our right angle, BCA, we've drawn an altitude to our hypotenuse. Label that point D. Because we've drawn an altitude, we know that angle CDA is a right angle, and we know that CDB is a right angle. That's the definition of an altitude. We know that an altitude forms a right angle as a side that is perpendicular to another side. So we have now 3 right triangles. We have our big triangle, we have the triangle on the left side, and the triangle on the right side. And last time we actually took a look at these triangles, we cut them up, we compared angle measurements with a protractor. I'm going to review quickly the proof of how we know that all 3 of these triangles are similar to one another. So I'm just going to start working in our big triangle now. All right, so our big triangle is ABC, triangle ABC. And we spoke last time about labeling our angles with Greek letters now, because we are now going for it. We're in the big leagues. We're not going to use X and Y. We're going to use Greek letters to label our angles and our triangles as we're doing our work in trigonometry. So I'm going to go ahead and label angle BAC theta. So angle BAC is theta. Now let's look at our large triangle. We know that in a triangle, all of our angles add up to 180 degrees. So this right angle here plus theta plus angle B adds up to 180 degrees. Or in other words, angle B plus angle A is 90. So if A is theta, then B must be 90 minus theta. B must be 90 minus theta. 90 minus theta plus 90. 90 minus theta Add theta, the thetas cancel. So 90 plus 90 gives us our 180. So we have our big triangle now. We know that angle A is theta and angle B is 90 minus theta. Let's look at the triangle on the left side now. This one right here. So there's my altitude. Triangle CDA. I know that angle CDA is 90. We've already established that angle DAC is theta. So we now know that angle DCA must be 90 minus theta. So I'm going to go ahead and now label my left side triangle. You can see, by the way, that I redrew my 3 triangles separately. Angle D is 90, A is theta, and C must be 90 minus theta. So we can see already how these triangles are similar to one another. We're using angle, 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 theta, theta, 90 minus theta, 90 minus theta, 90, 90. An important thing to note here is that I took triangle CDA and I reflected it. Okay? You can also rotate and reflect, but the big story here is that we took the triangle and we flipped it over so that now A is down here and angle C, now that is on top. You can't get there just by rotating the triangle. You have to reflect it or flip it. Okay, so there's our left side triangle, there's our our big triangle, and lastly is our triangle on our right side, where you know that we have angle B here, 90 minus theta, BDC is our right angle, and that means this angle down here, that must be theta. So there you have it. Our big triangle, the triangle on the left side, the triangle on the right side, they are all similar to one another. So let's write our similarity statement now. We know that triangle ABC is similar to ABC, ACD, order matters, CBD. AB to AC to CB, those are all in ratio to one another. BC to CD to BD. Oops, CB, excuse me, D in ratio to one another. And AC, AD, CD.